Look up at the night sky. What do you see? Countless stars glittering across a black velvet canvas. For millennia, humans have gazed upward, captivated by the mysteries of the cosmos. Stars are the building blocks of galaxies, the crucibles where elements are forged, and the engines that drive the evolution of the universe. Our journey begins with a simple question. What exactly are stars? The Sun is our closest star, a giant ball of hydrogen and helium, fusing atoms at its core to shine with life-giving energy. On a cosmic scale, its 93 million mile distance is practically next door. If the Sun were a basketball, Earth would be a peppercorn orbiting 25 feet away. The next nearest star, Proxima Centauri, would be another basketball over 4,000 miles distant. The universe is mostly empty space, with stars scattered like islands in a vast ocean. Our galaxy, the Milky Way, contains hundreds of billions of stars, each separated by these immense distances. But what if a star like our Sun appeared much closer? How would it change our world? Let's explore this cosmic what if. Stars are born in vast cold clouds of gas and dust called nebulae, cosmic nurseries shaped by gravity. Over millions of years, gravity pulls material together, forming a spinning disk with a hot, dense core. When the core heats up enough, nuclear fusion ignites and a star is born. Our Sun formed this way billions of years ago. These nurseries also give rise to planets, moons, and comets, everything needed for a solar system. In a sense, we owe our existence to these stellar birthplaces. Stars come in all sizes and colors, from red supergiants like Betelgeuse to tiny dense white dwarfs and neutron stars. Some giants could engulf Jupiter's orbit, others pack the Sun's mass into an Earth-sized sphere. Gravity and nuclear fusion shape their lives and deaths, creating the elements that make up planets and life. Without stars, the universe would lack the complexity and beauty we see today. Understanding stars means understanding the evolution of the cosmos. They are the universe's factories, forging the building blocks of everything. A star's color reveals its temperature. Blue means hot, red means cooler. Our Sun glows yellowish-white at about 5,800 degrees Celsius. Massive stars burn blue and live fast, dying young. Smaller stars glow red and can last trillions of years. By studying starlight, astronomers learn about a star's age, composition, and life stage. The color and temperature of stars are more than beautiful. They're clues to the universe's secrets. Every star tells a story through its light. The distances between stars are almost unimaginable. We use light years, the distance light travels in a year, nearly 6 trillion miles to measure them. Our nearest neighbor, Proxima Centauri, is over 4 light years away. Its light takes years to reach us. Observing distant stars is like looking back in time. The universe is a vast, mostly empty expanse with stars as distant beacons. Light years help us grasp the scale of space. The Milky Way spans about 100,000 light years, with our Sun a tiny speck halfway from the center. Even at light speed, crossing the galaxy would take thousands of years. When we look at distant stars, we see them as they were centuries or millennia ago. Beyond our galaxy, the distances become even more staggering. How do we measure star distances? Astronomers use parallax, the apparent shift in a star's position as Earth orbits the Sun. It's like holding out your finger and watching it move against the background as you close one eye, then the other. By measuring this tiny shift, we can calculate how far away a star is. For more distant stars, astronomers use other clever techniques. The Milky Way is just one of billions of galaxies. Our nearest major neighbor, Andromeda, is 2.5 million light-years away. Its light left when early humans first used tools. The Hubble telescope reveals galaxies so distant, their light began its journey billions of years ago. Gravity binds stars and galaxies together, shaping the universe on the grandest scales. Sometimes gravity can bring a new star close to our solar system. Imagine a new star, as bright as our sun, appearing just a light year away. It would outshine every other star, transforming our night sky and casting strange shadows. But its gravity would disrupt our solar system, threatening planetary orbits and even life on Earth. The cosmic balance would be thrown into chaos. The universe is full of wonders and dangers waiting to be discovered. Our solar system, for all its apparent stability, is a delicate balancing act. The planets, including Earth, orbit the Sun in predictable paths, held in their celestial dance by the Sun's gravity. But with the arrival of a new star, this cosmic choreography would be disrupted. The two stars, locked in a gravitational embrace, would begin to orbit each other, their paths determined by their relative masses and initial trajectories. This cosmic waltz could take on many forms. The stars might settle into a stable binary system, their orbits relatively circular and predictable, or their interaction could be more chaotic, their paths intertwining in a complex and potentially dangerous dance. But the gravitational influence of this stellar intruder wouldn't be confined to the two stars. The planets, caught in the gravitational crossfire, would experience significant perturbations to their orbits. Some planets might be pulled closer to the Sun, while others might be flung outwards, their once stable paths transformed into elongated ellipses. Earth, our pale blue dot, would be far from immune to this cosmic shakeup. The stability of our orbit, the very foundation of our planet's climate and seasons, would be threatened. A slight nudge in one direction or the other could have catastrophic consequences, plunging our planet into an ice age or transforming it into a scorching inferno. Beyond the gravitational upheaval, the arrival of a new star would unleash a dazzling and potentially dangerous cosmic light show. Stars, those colossal nuclear furnaces, emit a torrent of radiation across the electromagnetic spectrum, from harmless radio waves to energetic X-rays and gamma rays. While our atmosphere protects us from the most harmful forms of radiation emitted by the Sun, the radiation from a nearby star could overwhelm our planet's natural defenses. The intensity of this radiation would depend on the type and age of the star. Young hot stars emit far more high-energy radiation than older, cooler stars. If our stellar neighbor were a young massive star, the increase in ultraviolet radiation could strip away Earth's ozone layer, leaving life vulnerable to the Sun's harmful rays. The influx of high-energy particles could also disrupt satellites, interfere with communications, and even pose a threat to astronauts in space. But even if the radiation from our new stellar neighbor weren't directly harmful, it could still have profound effects on Earth. The increased light and heat could alter our planet's climate, potentially leading to runaway warming and making life as we know it impossible. The arrival of a new star would not only disrupt the orbits of the planets, but could also have a profound effect on their physical structures. The intense gravitational forces exerted by the two stars could rip apart smaller celestial bodies, such as asteroids and comets, creating a cosmic shooting gallery. These fragments, flung through space at incredible speeds, would pose a significant threat to the inner planets, including Earth. Imagine a barrage of cosmic projectiles, ranging in size from pebbles to mountains, hurtling towards our planet. While our atmosphere provides some protection, larger impacts could have devastating consequences, triggering widespread fires, tsunamis, and even global extinction events. But the gravitational chaos wouldn't be limited to the inner solar system. The outer planets, with their vast systems of moons and rings, could also be affected. The gravitational tug-of-war between the two stars could disrupt the delicate balance of these systems, causing moons to collide, rings to shatter, and even planets to be ejected from the solar system altogether. The once familiar structure of our solar system, a testament to billions of years of gravitational evolution, would be forever altered by the arrival of our stellar neighbor. It would be a time of both destruction and creation, as old celestial bodies are torn apart and new ones are formed from the debris. The arrival of a new star in our cosmic neighborhood would undoubtedly be a spectacular event, but would it spell doom for life on Earth? The answer, as with many things in astronomy, is it depends. The survival of life as we know it would hinge on a multitude of factors, including the mass, age, and trajectory of the intruding star, as well as the resilience of Earth's biosphere. A small, cool, and distant star might pose little threat to life on Earth, perhaps even enhancing the beauty of our night sky without significantly disrupting our planet's delicate balance. But a large, hot, and close star could have catastrophic consequences. The increased radiation, gravitational perturbations, and risk of asteroid impacts could combine to create a perfect storm, wiping out life on Earth or forcing it to retreat underground or to the depths of the oceans. The arrival of a new star would be a cosmic game changer, forcing us to reevaluate our place in the universe and the fragility of life itself. It would be a stark reminder that the cosmos, for all its beauty and wonder, can also be a chaotic and unforgiving place. Should a star of significant size drift too close to our Sun, the consequences for our solar system would be nothing short of catastrophic. The delicate gravitational balance that holds our planetary system in check would be thrown into disarray. Imagine for a moment a cosmic game of billiards, where the balls are planets and the cue ball is a massive star, its gravity shaking the very foundation of our celestial neighborhood. The most immediate and dramatic effect would be on the orbits of the planets. Planets, including our own Earth, are bound to the Sun by its immense gravitational pull. This force dictates our planet's path through space, determining the length of our year and the rhythm of our seasons. Introduce a new gravitational player into the mix, and chaos ensues. Some planets might be drawn inward, their orbits shrinking, and their years shortening as they whirl around the Sun at a faster pace. Others might be flung outward, their orbital paths elongating, their years stretching into centuries or even millennia as they navigate the gravitational tug-of-war between the two stars. Earth, caught in this cosmic maelstrom, would likely experience severe climate change. Our planet's delicate energy balance, reliant on the Sun's warmth and light, would be thrown into disarray. The consequences could be catastrophic, ranging from extreme temperature swings to dramatic shifts in weather patterns, making our planet increasingly hostile to life as we know it. Imagine a new star arriving in our cosmic neighborhood. The night sky would transform, constellations torn apart, new patterns emerging. Two suns could blaze overhead, flooding Earth with light. Nights might vanish, replaced by perpetual twilight. But this beauty comes with danger, intense radiation threatening life. Ecosystems could collapse under the strain, our once familiar sky now a harbinger of doom. Over time, the gravitational dance between the two stars and their retinue of planets would likely settle into a new equilibrium. This new order, however, would bear little resemblance to the solar system we know and love. Some planets might be ejected entirely, flung into the depths of interstellar space to wander alone as rogue planets, their journeys through the cosmos no longer tethered to the gravitational pull of a star. Others might collide, their violent encounters transforming once majestic worlds into scattered debris fields, a testament to the destructive power of gravity. Earth, if it survived the initial chaos, would find itself in a vastly different solar system. Its orbit might be altered, its climate irrevocably changed. The familiar cycle of day and night, of seasons and years, might be but a distant memory. Life on Earth, if it persisted, would have to adapt to this new reality, a testament to the tenacity and resilience of life itself. This cosmic upheaval, while cataclysmic in the short term, could pave the way for new beginnings. The debris fields left behind by planetary collisions could coalesce to form new planets, their births fueled by the ashes of destruction. These new worlds, shaped by the gravitational interplay of two stars, might harbor conditions suitable for life, a testament to the universe's capacity for renewal and reinvention. The universe is a place of profound mystery and breathtaking beauty. From the fiery hearts of stars to the vast spaces between them, the cosmos beckons us to unravel its secrets. The more we learn about the universe, the more we appreciate our own place within it. The atoms in our bodies were forged in the hearts of stars, scattered across the cosmos, only to reconvene on this pale blue dot we call home. The universe is vast, mysterious, and forever awe-inspiring. And we, the stargazers, are just beginning to unlock its secrets.